Geometry, Unit 3, Lesson 3. I can identify and use properties of rectangles and squares. So, we know the parallelogram. Let's do a very quick review for parallelogram. They have opposite sides are parallel. And opposite sides are congruent. I can mark that. Tick, tick, double tick, double tick. Okay, we already know that about a parallelogram. Now the angles, we know opposite angles are congruent. And we learned something else. If you extend these sides, you can see the transversal cutting the two parallel sides. And so these consecutive angles are going to be supplementary. Okay, and then last, consecutive angles, I should have put that right here. So consecutive angles are supplementary. And then finally, for diagonals, if you sketch them in, it's going to get a little busy up there. It turns out that they bisect each other. So those are all the rules to be in the parallelogram club. Now, the rectangle, let's take a quick look at it. Are its opposite sides parallel? Yes. Are its opposite sides congruent? Yes. Are its opposite angles congruent? Yes. So in fact, all of the rules for the parallelogram, the rectangle meets them. So an important question, is a rectangle a type of parallelogram? And the answer is yes, because all of these rules apply to the rectangle. But there's more rules for the rectangle. To be a rectangle, you have to meet all the parallelogram rules and have some more. Here are the key differences for the rectangle. Not only are opposite angles congruent, but they're all congruent because they're all 90 degrees. All the angles are 90. That's a huge difference. Okay. And are the consecutive angles supplementary? Sure. 90 plus 90 is 180. All those things are still true. But when we come down to the diagonals, we have something new. If I were to sketch the diagonal in, yes, they bisect each other. Tick, 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 tick. However, if you look at this diagonal here and this one here, they're the same length. So the other big difference is that the diagonals are congruent. Really important to see that. These two diagonals over here are not. Look at this one here. This one here is longer than this shorter one right there. And you can pick it up. This shorter one, nowhere near as long as the whole thing. But these are the same. So those are the two big differences. You have to meet all these rules and then have these two other things going on if you're going to make it to the rectangle club. But then check out the square club. The square club, if you think about it, are opposite sides going to be parallel? Sure. Are they also going to be congruent? Yes. Are all of do the diagonals bisect each other? Yes. All of these rules are true. So, is a square a type of parallelogram? Yes. Well, what about the square meeting these things? Are these true? Are all of these angles 90? Yes, they are. Do the diagonals, are they congruent? Yep. Let's sketch those in. So a square is not just a parallelogram, it's also a rectangle because it has all the rules of a rectangle as well. So is there anything extra you need to have besides these things to be a square? And the answer is yes, and here are the extra things. So if you take a look, opposite sides, like in a rectangle, are the same. But in a square, not just opposite sides, but every side. So one of the biggest differences here is all the sides are congruent. All four the same, where that's not true over here. And then the final big difference is down in the diagonals. If you look at these diagonals, they're kind of cool because what they end up doing is they end up bisecting the angles here. So this right here becomes 45 and 45. In fact, they all do. And there's one final thing. The diagonals are perpendicular to each other. So those are the extra rules here in orange that make you a square, that take you past being a rectangle and make you a square. So I'm going to come down here and say the diagonals, they are congruent, but they go further, and the diagonals are perpendicular. The diagonals also bisect the angles into 45 and 45. So those are the additional rules that make you a square, to have all the sides congruent and then perpendicular diagonals, and the diagonals bisecting the angles when they get to the corner. So I could go back and mark everything else up. I could put all these rules on these guys, but it's going to get pretty busy. I mean, you know these are parallel, and so on. I think it is important to show tick, 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 tick. Those are all single ticks because they're the same length. Unlike over here, I couldn't do that. So these highlights are the new things, and I'm going to come down here and I just want to make sure we can understand the differences between rectangles and squares. The similarities first, though. What's similar about them? Well, both have all the rules of a parallelogram, so both a rectangle and square are parallelograms. All their angles are 90 degrees, and their diagonals are congruent. All those things are true between a rectangle and a square. But what's the difference? All the sides are congruent here, whereas they're not over here, only opposite sides. And the diagonals here are perpendicular, and they bisect the angles. So the big difference is a square has all sides congruent, and a square's diagonals are perpendicular and bisect the angles. Those are the big differences. Okay, so I just want you to think about this. If everybody in this group is a quadrilateral, having four sides, then this next group right here might be those quadrilaterals that are parallelograms. But then there are parallelograms that have all their angles that are 90. We call those rectangles. Wait a minute. If they also have perpendicular diagonals and all their sides are the same length, then we can call them squares. So look how you can get more and more specific. And the question is, do you have enough evidence to say which group you can be in? Okay, so a little bit of guided practice and we're done. Use rectangle STVU. As soon as you see that word, you better highlight it because that lets you now use all of the rules we just talked about. For example, I can come over here and say, oh, I know that all of these corner angles now are 90 degrees because it told me it's a rectangle. I know that this diagonal and this diagonal are the same length. I know the opposite sides are the same length. You know all these relationships. So in fact, let's look at number 1. We're trying to find each measure, and if the measure of angle 4 is 30, in just this problem, it's going to change in the next one, but if the measure of angle 4 is 30 degrees, what's the measure of angle 3? Well, the relationship here is they're complementary. And the equation would be the measure of angle 3 plus the measure of angle 4 has to equal 90. How do I know it's 90? I know it's 90 because they told me it's a rectangle. So if they told me it's a rectangle, the corner angles have to be 90. That's how I got the relationship. They're complementary. So 30 plus the measure of angle 4 is 90. And if you take away 30 from both sides, the measure of angle 4 is going to equal 60. What about the measure of angle 8? Measure of angle 8 is right here. If it was 115, what would be the measure of angle 1? And you guys should be able to cover this up and see that that's a linear pair right here. Measure of angle 8 and 1. So the relationship is a linear pair, which you guys know really means supplementary. So I can say the measure of angle 1 plus the measure of angle 8 equals 180 degrees. Well, the measure of angle 1, I don't know. But the measure of angle 8, is 115. And if you take 115 from both sides, you're going to be looking at 65. Let's do one more. The measure of angle 7 is 25. And what's the measure of angle 4? Now remember, this isn't 30 anymore. I can erase those. So if this one up here is 25, what's this one? This is maybe the single hardest thing to see. I'm going to get my highlighter here. Remember to see a picture in a picture. I want you to see this and this, and then I want you to see this transversal. If you can see that, then you might be able to see how here's angle 7, here's angle 4. So if you can see what I'm talking about, I sketched this right here. Here's angle 4, here's angle 7. That's what's in pink. What's the relationship here if these are parallel? Which they are because it's a rectangle. The relationship is alternate interior, and you can see they're congruent. They're both acute. So alternate interior angles are congruent is the relationship. So what you want to say is the measure of angle 7 is equal to the measure of angle 4. And in this case, 25 is equal to the measure of angle 4. It's very, very challenging to see that relationship inside. Please, please look for them. And remember the properties to help you figure out the relationship and then the equation. Good luck.